I'm Joe Graydon.
And I'm Terry Graydon. Welcome to this podcast of the People's Pharmacy.
You can find previous podcasts and more information on a range of health topics at peoplespharmacy.com. If you had a rare disease, doctors might find it interesting, but they also might not know much about how to treat it. This is the People's Pharmacy with Terry and Joe Graydon.
Rare diseases pose a huge challenge to the medical profession and even more to the patients who suffer with them. Relatively few people are diagnosed with any specific rare condition. However, there are nearly 7,000 rare diseases in the medical books, and altogether nearly 10% of the population is affected.
When a medical student nearly died of Castleman disease, finding a cure was a matter of life and death. His story is compelling.
Coming up on the People's Pharmacy, Chasing My Cure, a doctor's race to turn hope into action. In the People's Pharmacy Health Headlines, saline nasal irrigation, starting immediately after a COVID-19 diagnosis, can help ease symptoms and protect people from hospitalization. Saline irrigation is a tradition that goes back centuries in Southeast Asia, where people regularly use neti pots. However, it's relatively unfamiliar to Americans. The study was conducted in Augusta, Georgia in 2020. Scientists recruited 79 overweight older adults to flush their sinuses with saline twice a day. They began within 24 hours of testing positive on a PCR COVID-19 test. The investigators contacted the volunteers every few days to collect data on their symptoms for a month after diagnosis. One participant made a COVID-related visit to the emergency department, and another was hospitalized. None died. In comparison, the CDC reported that 9.5% of COVID-positive patients were hospitalized during that time frame, and 1.5% died. The researchers point out that sinus rinse bottles for saline nasal irrigation are inexpensive and easy to use. Widespread use could save lives.
Most Americans seem to believe that the pandemic is over. They've resumed in-person meetings, dining in restaurants, attending sporting events, and America's favorite pastime, shopping. Most are not rushing to get either the bivalent booster or a flu shot. Influenza was especially bad in the southern hemisphere this year. Australia experienced its worst flu season in 5 years. In the U.S., influenza cases are just beginning to be detected, with type A H3N2 predominating. The vaccines for this year include type A H1N1 and H3N2 and type B Victoria and Yamagata. COVID cases are now rising in the UK, Italy, France, Austria, Switzerland, and Taiwan. Usually, the U.S. follows a similar pattern after a delay, suggesting we could see cases starting to rise again in coming weeks. A recent study of more than 10 million North Carolinians shows that COVID vaccinations cut the rate of infections nearly in half. More importantly, the risk of hospitalization and especially the risk of death were dramatically lower among vaccinated individuals. Although protection against catching COVID fades over time, the protection against severe illness and death seems to remain quite strong.
An old wives' tale holds that eating fish is good for your brain. Now, scientists at the University of Texas have shown that the old wives were right, once again. Investigators measured blood levels of omega-3 fatty acids in more than 2,000 volunteers. Participants also answered test questions to determine their cognitive capacity and submitted to brain scans that measured brain volume. Omega-3 fatty acids are abundant in cold water fish such as anchovies, sardines, salmon, trout, and tuna. People with higher levels of omega-3 fats in their blood performed better on cognitive tests and had larger hippocampal regions. This area of the brain is associated with memory.
Another source of omega-3 fatty acids is the tiny crustaceans in Antarctica called krill. Krill oil is a popular dietary supplement rich in both EPA and DHA. A randomized controlled trial from Australia, published in the American Journal of Clinical Nutrition, evaluated whether krill oil could ease arthritis pain. Patients had mild to moderate osteoarthritis of the knee. After 6 months, those taking krill oil reported less knee pain and stiffness and better physical function compared to people taking placebo. No safety concerns were reported.
There's been a lot of buzz around time-restricted eating, but studies have reached inconsistent conclusions. Now, 2 new trials reported in Cell Metabolism suggest that eating breakfast, a light lunch, and no supper may be especially helpful. In one of the studies, 16 overweight people ate standardized meals early or late while researchers measured hormone levels. People who ate early reported feeling less hungry. In a second study, 137 firefighters adhered to a 10-hour window or ate throughout the day. Those practicing time-restricted eating had better blood sugar, blood pressure, and blood lipid levels. And that's the health news from the People's Pharmacy this week. Welcome to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon.
Rare diseases can sometimes be very hard to diagnose and even harder to treat. Medical student David Fajgenbaum was an elite athlete as well as a brilliant scholar. Then, in July 2010, his body suddenly started falling apart. His kidneys and liver were failing, and his bone marrow was not functioning normally. He nearly died.
For the story of his diagnosis and treatment, we turn to the expert himself. Dr. David Fajgenbaum is an assistant professor of medicine at the University of Pennsylvania. He is associate director of the Orphan Disease Center and the co-founder and executive director of the Castleman Disease Collaborative Network. He's also co-founder of the National Students of Ailing Mothers and Fathers Support Network. Dr. Fajgenbaum was awarded the Rare Champion of Hope Award for Science and is the author of Chasing My Cure, a doctor's race to turn hope into action.
Welcome to the People's Pharmacy, Dr. David Fajgenbaum.
Thank you so much for having me today.
Dr. Fajgenbaum, you've had an extraordinary experience with a life-threatening illness. Please tell us what was going on when you first suspected something bad was happening inside your body.
Sure. I was a healthy third-year medical student. I had never had any issues whatsoever. And all of a sudden, I noticed that I was a little bit more tired than usual. I noticed some bumps appearing in my neck and some fluid accumulating in my ankles. As a medical student, I had seen symptoms and signs like this in patients, but certainly never in myself. And the fatigue continued to get worse and worse. And eventually, I went just down the hall from where I was taking care of patients to the emergency department, and they ran blood tests, and they said, David, your liver, your kidneys, and your bone marrow are shutting down. We have to hospitalize you right away. And that was the beginning of a frightening and months-long journey to get to a diagnosis.
Oh, well, that is frightening, and that was bad news. Tell us a little bit more about the course of your decline.
Sure. So shortly after hospitalizing me, I had a retinal hemorrhage and went blind in my left eye. I started gaining fluid all over my body. I gained 70 pounds of fluid. My kidneys had stopped working. My liver wasn't working, so I was on dialysis. I was getting daily blood transfusions. I was completely out of consciousness, and I was receiving any nutrition through my feeding tube in the intensive care unit at the same hospital that I'd been treating patients at just days before, all without a diagnosis. And it continued to be such a frightening time in my life, but also for my family and my friends that were there watching me literally dying in front of their eyes without a diagnosis.
What's so extraordinary about this story, Dr. Fajgenbaum, is that you were in unbelievably great physical shape. I mean, we've seen pictures of you as a football player, for example. We understand that you were able to bench press some astonishing amount of weight, like over 350 pounds.
That's right.
And your friends called you the Beast. Tell us a little bit about your physical prowess.
That's right. So I grew up in Raleigh, North Carolina, and playing football, and my dream of playing college football was really all I could think about growing up. And I had the opportunity to play football at Georgetown, and just as you said, my nickname was the Beast because I was so physically fit and so strong and so healthy. And I ate exquisitely well. I exercised all the time. I was even a personal trainer, doing anything I could to improve my fitness and my health. And so the contrast was just frightening and shocking for me to see me go from such a healthy person to just in the matter of days dying in the intensive care unit and looking less like a beast and looking more like I'd been attacked by a beast.
And dying of something your doctors could not figure out what was going on. Tell us more about that.
That's right. So at this stage, I'd been hospitalized in critical condition for weeks without a diagnosis, and my doctors were running out of options, and I was running out of time. And I was actually medically evacuated down to North Carolina to a hospital there where I continued to worsen, but they were able to keep me alive. And after the course of about 11 weeks, I was eventually diagnosed with a disease called idiopathic multicentric Castleman disease, which is a rare immune system disorder where basically your immune system gets activated and starts attacking all of your vital organs for no known reason and no cause. And so at this stage, I got the diagnosis, but I was so sick 2 days before I was finally diagnosed that I actually had my last rites read to me by a priest. My doctors didn't think I would survive and encouraged my family to prepare for me to die. And so I had a priest come in and administer my last rites. But thankfully, with the diagnosis came the start of chemotherapy. And so I was treated with chemotherapy, and that chemotherapy saved my life. So whereas I'd been at the brink, chemotherapy saved my life. But unfortunately, this was just the beginning, and I would go on to have relapse after relapse.
Now, before they figured out what was going on, what were some of the possibilities that they were considering?
It was a range of things. Number one on the list was lymphoma. They thought that I had a very aggressive lymphoma, and being a medical student, I was a third-year medical student at that stage, so I had been treating patients in hospitals, and that's what I suspected, that I had an aggressive lymphoma. I also had what appeared to be like sepsis with the multi-organ failure that often comes with sepsis, so we thought maybe I was septic. We thought maybe I had a really aggressive autoimmune condition, or maybe there was some sort of virus that we couldn't detect, but maybe something like a super virus that was killing me. But what we ended up finding was that I have this disease, idiopathic multicentric Castleman disease, which is kind of like a mix of all of those things. And in fact, so little research has been done that we don't know whether to categorize it as a cancer or an autoimmune disease. And so I have this hybrid disease that's really devastating.
So your parents, of course, I mean, your whole family must have been devastated when you were basically informed that you didn't have much time to live. And then you get this diagnosis that's kind of weird. It's a rare disease. And I'm sure as a medical student, as you began to recover with the chemotherapy, you started to look up, well, what is Castleman disease and what's the prognosis?
That's right. And I got some pretty bad news. And, you know, I'd been hoping and praying for a diagnosis because I just wanted to know what this was so we could start to treat it. But actually, I wasn't terribly thrilled when I found out what it actually was, because I did what most people do, and I went to Google on my phone, and I was kind of out of it because my organs weren't working so well. But I do remember that I came across a paper, one of the few papers that existed at the time on Castleman disease, and it specifically said that that only 1 in 5 patients back when the study was done survived more than 2 years after diagnosis. And here I was, 25 years old, and I knew what I had was really severe. I knew it was really bad. I mean, it had almost killed me, just that first time. But it was scary to see the numbers and numbers that I've read a lot of medical papers in medical school, and certainly the meaning it took a different meaning when I had that disease. And we now know that about a third of patients with my disease will die within 5 years of diagnosis, and another third of us will die within 10 years of diagnosis. So we've made strides, but unfortunately we still have a long way to go.
In order to know what proportion of patients are going to die within a given amount of time, you have to know who's got the disease. Just how rare is Castleman disease?
About 5,000 patients are diagnosed each year in the U.S., so it's about as common as ALS. ALS also affects 5,000 new cases each year in the U.S. Of course, ALS has significantly more awareness, and it needs more because ALS is such an awful disease, and we need to raise more awareness for it. But there's also many other rare diseases like Castleman disease that are equally rare, but that really have much less public awareness.
Now, you were given initially massive doses of corticosteroids, and these are, powerful drugs. It's kind of a blunderbuss approach. And then you also had chemotherapy, which people hear and they go, oh, that's pretty hard on the body too. Tell us, how you did with steroids and those kinds of doses and chemo, and how well did they work?
Sure. So the chemotherapy really is what saved my life, and it saved my life now 4 times where I was up against the brink. And just to give a perspective for how sick I was before I got the chemotherapy, I actually felt better with every single dose of chemotherapy. I mean, just to get a sense for how sick I was, these are drugs like adriamycin, Cytoxan, etoposide. These are you consider some of the nastiest drugs with the worst side effects in the world. But I was so sick that I actually felt better with every dose of these drugs because they were finally starting to kill my disease, which was trying to kill me.
Dr. Fajgenbaum, what did you learn from being at death's doorstep?
So I've now nearly died 5 times, and with each one of those experiences, I've learned a lot about life and about living from nearly dying. The first time I almost died, I spent a lot of time reflecting on my life and what I did, what I didn't do, and I realized I didn't regret a single thing that I had done or I had said. I just regretted the things that I had not done or I had not said to the people that I loved, things that I never would be able to do in the future, which has led me to live by this motto of think it, do it, that I'm not going to think of something and then not do it or not tell someone how I feel about them for the rest of my life. If I survived, I would live by think it, do it. It's also made me realize that I'm in overtime, and in overtime, every second counts. And so I live with this sense that I need to make the most of every second because, we can't take any time for granted. And I think that's a lesson that applies to anyone, not just me, not just someone who can hear the clock because of what I have, but all of us.
You're listening to Dr. David Fajgenbaum. He is an assistant professor of medicine at the University of Pennsylvania and associate director for the Orphan Disease Center. Dr. Fajgenbaum is also the co-founder and executive director of the Castleman Disease Collaborative Network and co-founder of the National Students of Ailing Mothers and Fathers Support Network. Dr. Fajgenbaum was awarded the rare Champion of Hope Award for Science and is the author of Chasing My Cure, A Doctor's Race to Turn Hope into Action.
After the break, we'll find out how common rare diseases actually are. How many people suffer?
Dr. Fajgenbaum found that an existing drug might help his condition. What medication is he taking?
And how well does that medication work?
You'll also learn about the mTOR pathway and find out why you should care about it.
How can we go about putting old drugs to new uses for rare diseases? Will insurance pay if the medicine is off-label?
You're listening to The People's Pharmacy with Joe and Terry Graydon.
This podcast is made possible in part by Gaia Herbs. For more than 30 years, Gaia Herbs has nurtured the connection between people and plants to deliver nature's vitality. Their full-spectrum formulas are designed to provide an herb's complete array of beneficial compounds with nothing artificial to get in the way. Learn more at GaiaHerbs.com. That's GAIA herbs.com. Welcome back to the People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon.
The People's Pharmacy is brought to you in part by CocoVia, the maker of high-potency cocoflavanol supplements that support cognitive and cardiovascular health. More information at cocovia.com.
Also by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Online at verisana.com.
Today we're talking about rare diseases. Finding treatments can be an extraordinary challenge.
Our guest is Dr. David Fajgenbaum. He is Assistant Professor of Medicine in the Department of Translational Medicine and Human Genetics at the University of Pennsylvania. He's also Associate Director for Patient Impact of the Orphan Disease Center at the university and co-founder and Executive Director of the Castleman Disease Collaborative Network. His book is Chasing My Cure, a doctor's race to turn hope into action.
Dr. Fajgenbaum, you have what is called a rare disease. And I'm curious how many people, you told us once, let's have it again, how many people actually have the kind of condition you have, which is a subset of Castleman disease. And then if you could tell us a little bit more about rare diseases in general. It's our understanding that rare is not all that rare if you think about 30 million people who may be affected by a rare disease.
That's exactly right. So Castleman disease affects about 5,000 new patients each year in the U.S., so it's about as common as ALS. But my subtype, idiopathic multicentric Castleman disease, which is the most deadly and the least well understood, affects about a third as many. So it's about 1,500 new patients diagnosed each year with my subtype. And just as you said, though each one of our rare diseases is rare, collectively there are 7,000 rare diseases that affect 30 million Americans. So 1 in 10 Americans have a rare disease. And unfortunately, 95% of those 7,000 diseases do not have a single FDA-approved therapy, not even one. And so though as a medical community we have a lot to be proud of and a lot to be thankful for with the progress we've made, for many rare diseases, in fact, most rare diseases, there's still a lot of important work that needs to be done.
Well, that brings me to my question. You have described how your idiopathic multicentric Castleman disease was treated with chemotherapy, very, very toxic drugs. Mm-hmm. I can't imagine your doctors or you would want to stay on them for a really long time. You have come up with different treatment. Can you tell us, how did you figure that one out?
Sure. So fortunately, as I shared earlier, chemotherapy saved my life. But unfortunately, I went on to relapse about a month later. And this time I needed 7 different chemotherapies all at once at maximum tolerable doses.
Yikes.
To save my life. Yes,
I can't even imagine what that must have been like.
Yeah, it's really kind of the 7 worst poisons that are known to man that, we give to patients like myself to just try kind of as a last-ditch effort. And it was awful. But I was so sick that I needed those drugs to save my life, and they did save my life. I spent 7 weeks hospitalized, but I eventually walked out of the hospital. I was eventually able to stop dialysis, eventually able to stop getting daily transfusions. But it was a really difficult time, but thankfully chemo did save my life. Right around that time, I was started on an experimental drug, a drug that had been developed for Castleman disease, for my subtype of Castleman disease, and that I was very hopeful would keep me in remission for a long time. So I actually returned back to medical school at the University of Pennsylvania on this drug, this experimental drug, every 3 weeks, hopeful that it would never come back. And I hoped and I prayed that researchers somewhere would continue to advance research and that this drug would work for me and keep me in remission for a long time. But unfortunately, about a year later, I had a full-blown relapse on this drug. And this was a really important turning point in my life because there I was, back in the hospital with my doctor, who is the world's expert. And I started to ask him questions. Okay, this drug, this experimental drug I'm on didn't work, but what other experimental drugs are coming down the pipeline? And he said, there aren't any. And I said, okay, well, are there any new leads like cell types or signaling pathways for things we can go after with drugs? He said, no, there aren't any. And I said, okay, well, are there researchers out there that are conducting promising research that, maybe is going to identify something soon? And he said, no, there aren't. And within about a 5-minute conversation, I went from being this very hopeful medical student who believed in the power of science and technology and medicine to solve problems to all of a sudden realizing that I was completely alone. The cavalry was not coming. And I turned to my dad and my sisters and my girlfriend, and I told them, I said, I'm going to dedicate the rest of my life, however long that may be, to trying to identify treatments and a cure for my disease. And they kind of looked at me like, okay, Dave, let's just get through, tomorrow. You're really sick. Let's get through tomorrow. But I realized I could no longer, if I wanted a treatment, if I wanted a cure, I could no longer hope and pray for someone else somewhere to identify a treatment or a cure. I would need to get to work trying to identify one myself. And so when I recovered, I got chemotherapy again and I recovered, and my life was saved for the 4th time. But this time I returned to medical school and I started conducting laboratory research on my own samples. I started doing work studying my samples, and I created a foundation called the Castleman Disease Collaborative Network with the goal of accelerating research internationally for Castleman disease. And we started making some really exciting progress over the next few months, but unfortunately, I ran out of time and I had another relapse. Despite my best efforts, despite the experiments I was running, I relapsed and I nearly died for a 5th time. And so for a 5th time, I approached death's doorstep. This time I was engaged to my girlfriend at the time and was so hopeful that we would just be able to make it to our wedding date, May 24th of 2014. Just wanted to make it to that date. Fortunately, chemotherapy saved my life again. But this time when I left the hospital, I realized that there was no way I would make it to our wedding date unless I myself identified something that could save my life. And so I went back to the lab and I spent days and days and nights trying to identify a potential drug that could maybe save my life. And from the experiments and from weeks of data and study, I identified a pattern in my data that suggested to me that a drug that was developed 25 years ago for kidney transplantation might actually help my disease, a drug that had never been used before for Castleman disease, but was already FDA approved for other conditions. And I shared the data with my doctors. And at this stage, I had finished medical school, but I shared the data with my doctors. And in the absence of any other solutions or options, we decided to start me on this drug as the first Castleman's patient ever. And today is over 5.5 years since I started that drug. I nearly died 5 times in the first 3.5 years. And now I'm sitting here on the show with you guys 5.5 years later, thanks to this drug that's saving my life.
Tell us, what is the drug and a little bit more about it?
Sure. It's called sirolimus, and it works by inhibiting an important pathway or communication line in the immune system that's important for inflammation and immune activation. And I found from my data that that particular communication line was very activated in my samples. And though that didn't guarantee that inhibiting it would work in my disease, it at least was a lead that I was interested in pursuing. And so we started me on this drug, as I mentioned, and we've actually now performed quite a bit of additional research on other patient samples. I should also mention that after medical school, I enrolled in business school here also at Penn at the Wharton School to try to develop skills around improving organization and management within the rare disease space, particularly for Castleman disease, but how can we improve collaboration, strategic use of funding and samples. And so in business or after business school, I ended up getting a position here at the University of Pennsylvania to create a center to study Castleman disease and to begin conducting laboratory work and also clinical trials in Castleman disease specifically, and also a leadership role within the Orphan Disease Center. And so I'm here in Philadelphia, and I spend my life. I've dedicated my life and my career to studying Castleman disease.
Now, you are taking, I take it, sirolimus.
That's right.
How about other Castleman disease patients? Are other people also taking this medication? As you said, the medication is FDA approved, but not for Castleman disease.
That's right. So we're aware of probably around 15 Castleman disease patients that have been treated with sirolimus. And about half of those patients we have observed or heard that the drug has worked for them and has resulted in an improvement. But about half of the patients that have been treated with it, it has not helped them. And so we recognize, and I mentioned that experimental drug that I was on initially, that drug went on to get FDA approval for Castleman's. It works for about a third of patients. So now we have a situation where that drug works for about a third, and sirolimus will probably also work for some portion of the remaining patients that first drug doesn't work in. But we're constantly looking for new drugs and new treatments and ways to help Castleman disease patients like myself.
What's so extraordinary about your story is that you actually kept very careful records. In fact, you gave blood periodically during the course of your disease, and then you went back and you tracked your immune system to see what was going on prior to one of these terrible attacks. And that's what led you to make some of the discoveries that you did to say, wait a minute, my immune system is going haywire here. What can we do to intervene? And for people who are not familiar with sirolimus, I mean, this, as you said, was a drug originally developed to prevent organ rejection. How well is it tolerated? And tell us a little bit about this mTOR pathway that is so critical to how well it works.
Sure. So you're exactly right. Sirolimus has been around for a long time, and it was initially developed as a way to suppress the immune system if you were to get an organ transplant. Because if you were to get a kidney transplant, your immune system would want to reject that organ. It would consider it foreign. But researchers were actually able to determine that if you give drugs like sirolimus, some other immunosuppressants as well, that you can actually suppress the immune system and prevent your immune system from rejecting that organ. And what we've learned subsequently is that the mTOR pathway, which stands for mammalian target of rapamycin, that particular pathway which this drug works on is really critical for immune hyperactivation generally and proliferation of immune cells. These are problems that we observe in Castleman disease. And so it became quite exciting to think about a drug that targets some of the key components of Castleman disease. As you mentioned also, this drug is approved for one indication and it can be used for others. And I think this actually shines some interesting light on an important opportunity in medicine. And that's that I mentioned earlier that there are 7,000 rare diseases, 95% of which do not have a single FDA-approved therapy. But there are 1,500 drugs that are FDA approved for at least one condition. And so something I'm very interested in working on quite a bit is trying to understand, of the 1,500 drugs already FDA approved, how many other diseases may those 1,500 drugs potentially be able to work in? How many other diseases that don't currently have any treatments may there be a drug like sirolimus that could be life-saving? And I think about in my case, for those first 3.5 years when I was in and out of the ICU, I kept walking past my neighborhood CVS, and in that neighborhood CVS was sirolimus in that pharmacy. But of course, no one, myself included, had ever thought to try it. So how many other drugs are there out there that are already FDA approved that could be treatments or cures for patients that don't currently have any?
I have to admit, that just fascinates me, especially for conditions, well, like cancer, for example. I mean, there are some very interesting developments over the course of the last decade or two where we've learned drugs like metformin. I mean, it's been around for decades. It was originally developed from French lilac. And, here is a drug that is taken by tens of millions of people all around the world for type 2 diabetes. But there's also some data to say, well, wait a minute, it might be helpful in preventing certain cancers or preventing metastases and recurrence. So there may be gold in them hills that we haven't even discovered yet.
That's exactly right. I mean, when you as a physician scientist myself, we're always thinking about the next new drug to develop, the next new pathway to find. But I really encourage my colleagues, and I'm currently working actively with the FDA to say we need new drugs to be developed, but we also need to look back at all of these other drugs that we've already developed, like metformin, like sirolimus, like zoltuximab, drugs that are already FDA approved, and really make sure that we're utilizing all of these drugs to their fullest potential.
Dr. Fajgenbaum, there's one little fly in the ointment, and that is that the FDA approves drugs for certain indications. As in the case of sirolimus, the indication is for organ rejection. Insurance companies look for excuses not to pay for medicine. And so if sirolimus hasn't been approved by the FDA for Castleman disease, will they pay for it?
Yeah, this is a great question, and it's really important because, as I said, I'm a big proponent for this concept of off-label drug use, or at least rational off-label drug use, where you have data to support potentially trying a drug for a disease that it's not yet indicated for by the FDA. And so, just as you said, a doctor can prescribe a drug for any reason that he or she wants to prescribe that drug for. So you can prescribe sirolimus for heart disease. You can prescribe it for whatever disease you want to prescribe it for. But to your point, the insurance company or the payer gets to decide whether or not they're going to actually pay for this drug. And so you need to both have data that's going to support a physician making the decision to try it, and you need data to support an insurance company covering the drug. And so, I mentioned earlier that we're only aware of about 15 Castleman disease patients being treated with sirolimus, and that's because we have not done a clinical trial as of yet, or at least we just started enrollment 2 weeks ago. So we enrolled our first patient last Monday. So we need to do this clinical trial so that way clinicians and physicians around the world will know, well, how well does this drug work in a rigorously evaluated fashion? So you need the clinical trial data so that physicians can make an informed decision, and you also need that clinical trial data so that insurance companies can say, yes, this makes sense or it doesn't make sense. In the absence of a clinical trial, and in the case of Castleman disease with the insurance company when they were considering my drug, I had already failed all previous options. And I am a very expensive patient when I'm in the hospital. I mean, I rack up huge bills because all of my organs are failing. And so the insurance company actually didn't give us any problems with paying for this drug. And I think it's probably a combination of I had exhausted all previous options. If I'm not treated, I will immediately be hospitalized and I will cost lots and lots of money. And then on top of that, there was at least some data and some rationale for why we would want to go after this particular pathway. Oh, and also sirolimus is much cheaper than a lot of other drugs. And so I think those combinations of things meant that it worked for me. But to your point, as we think about this much more broadly beyond Castleman disease, beyond chasing my cure to chasing our cures, we really need to consider all these important factors.
You're listening to Dr. David Fajgenbaum. He's Assistant Professor of Medicine in the Department of Translational Medicine and Human Genetics at the University of Pennsylvania. He's also Associate Director for Patient Impact of the Orphan Disease Center at the university and co-founder and Executive Director of the Castleman Disease Collaborative Network. His book is Chasing My Cure, a doctor's race to turn hope into action.
After the break, you'll hear Dr. Fajgenbaum's proposed clinical trial of sirolimus for Castleman disease.
Do we have any better handle on what Castleman disease actually is?
Dr. Fajgenbaum has set up a collaborative team to study Castleman disease. Could this be a model for other rare diseases?
You're listening to The People's Pharmacy with Joe and Terry Graydon. This podcast is made possible in part by CocoVia, maker of high-potency cocoflavanol supplements. Cocoflavanols are among the most well-studied plant-based nutrients, backed by 20 years of scientific research.
CocoVia Cardio Health is available in capsules or powder, providing 500 milligrams of cocoflavanols daily. This supports better blood flow and vascular performance.
CocoVia also offers Memory Plus, a supplement with 750 milligrams of cocoflavanols. This product is backed by 4 different clinical studies demonstrating significant improvement in several aspects of memory.
CocoVia Flavanols offer you all the benefits of chocolate without the sugar. Get 15% off your order by using the discount code PEOPLES15. That discount code, PEOPLES15. More information at cocovia.com. Welcome back to the People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. The People's Pharmacy is brought to you in part by Cocovia, offering plant-based nutrients in the form of cocoflavanols for brain and heart health. Online at cocovia.com.
And by Kaya Biotics, probiotic products made in Germany from certified organic ingredients. KAYA Biotics.com.
We're talking today about a rare disease called Castleman disease and an amazing search for a cure.
Our guest is Dr. David Fajgenbaum. He is an assistant professor of medicine at the University of Pennsylvania. He's associate director for the Orphan Disease Center and the co-founder and executive director of the Castleman Disease Collaborative Network. He's also co-founder of the National Students of Ailing Mothers and Fathers Support Network. Dr. Fajgenbaum was awarded the Rare Champion of Hope Award for Science and is the author of Chasing My Cure, a doctor's race to turn hope into action.
Dr. Fajgenbaum, it's exciting to hear that you're conducting a trial of sirolimus for people with Castleman disease. How big do you anticipate your trial will be? How long will it go? What will you be looking for? How do you conduct a clinical trial for something like this?
It's a great question. We're planning to enroll 24 patients over 1 year, and then we will treat each of those patients for a year on this drug. We have decided to focus the trial just on patients who have already received the one FDA-approved drug, siltuximab, and that drug did not work for them. Because as a researcher and also as a patient with the disease that I study, we're most focused on identifying treatments for patients that don't yet have options. And so we want to make sure that we are focusing on the patients with the highest unmet medical need. When you have a rare disease like Castleman disease, you have limited resources, limited funding, and so you need to make sure that every dollar counts. And we talked earlier about how rare diseases like Castleman's, most of us don't have any already FDA-approved drugs. So when we do clinical trials, we need to make them count. So we're focusing on patients who've already failed siltuximab. They're in the midst of active disease, and we'll treat all 24 of them. As I mentioned, we've just enrolled our first patient last Monday. So we'll treat all 24 of them, and we'll evaluate their laboratory changes after the drug's given and also their clinical response. And we hope that patients will improve on drug and that we'll be able to demonstrate that this is a drug that's effective for a large portion of patients. But of course, we have to do the trial because we won't know the results certainly until we have the data back.
And this is a trial in which everyone in the trial will get the drug. You don't have people who will be getting placebo because that would be tantamount to letting them die.
That's right. For diseases like Castleman disease, where there's such a high mortality rate and they're so aggressive, it's unethical to have a placebo arm in a trial like this. From a scientific and a research perspective, there's certainly pros to having a control arm, but I can tell you from a patient perspective and also from someone who is so deeply committed to advancing research for patients, we felt that it was most appropriate to not have a control arm.
One of the reasons it took so long for your doctors to diagnose what was wrong with you when you were so very sick is that nobody's really clear on what exactly Castleman disease is, what causes it. Have you gotten any more hints on the etiology?
You're absolutely right. It's called idiopathic multicentric Castleman disease, the idiopathic meaning we don't know the cause of it. We still don't know what causes the immune system to do what it does. But since I started the foundation called the Castleman Disease Collaborative Network back in 2012, we have been able to make a tremendous amount of progress. And in fact, we've been able to understand, though we don't know why the immune system goes out of control, we're able to understand which immune cells are the ones that are getting out of control. we have been able to do experiments to look for a potential virus that could be causing it. And we can say quite confidently that there is not a virus that's causing Castleman disease. We think that there's likely genetic mutations underlying why the immune system gets out of control. We're doing a lot of work in my lab and in other labs to tease apart these initial hits that we've gotten in the lab. And so we're hot on its tail. We're chasing after Castleman disease, and we're starting to understand what it is. We still don't totally understand why it happens, but all of these are critical questions that we need to answer to better treat patients. It's really hard to treat a disease if you don't know what it is or why it happens.
Dr. Fajgenbaum, there are, as you have already described, thousands of rare diseases. It may involve, a handful of patients. It may involve a couple of thousand patients, but not hundreds of thousands or millions, generally
That's
speaking.
Right.
And so one of the great challenges is funding. For a clinical trial like the one you're conducting, these are not inexpensive studies. Drug companies have figured out that they can make a lot of money off orphan diseases, and that wasn't the original intent. When the Food and Drug Administration passed the Orphan Drug Act decades ago, the thought was, well, nobody will make any money, so we have to incentivize drug companies. We'll give them tax breaks, we'll give them some other benefits, because they're doing something for the good of humanity, even if they won't make a big profit. Well, nowadays, drug companies can charge literally a couple $100,000 for a year's treatment for a rare disease. That's to develop a new drug. But you're looking at an old drug that's off patent, so no drug company is going to want to fund your clinical trial. How are we going to pay for the kind of research that you're doing with Castleman disease and literally hundreds, if not thousands, of other conditions that are rare for which people are really suffering and dying?
These are really important questions, and you're exactly right. When it's a new drug being developed, pharmaceutical companies do have the funding to do these sort of large trials to demonstrate efficacy and get approvals. And when they do get those approvals, just as you said, they're currently charging really high amounts on a year-to-year basis for these rare disease drugs, these orphan drugs. And just as you said, drugs that are already approved for something else, they're already priced at generally a low price, especially if they're already generic. So they're cheap drugs relative to the typical orphan disease drug. But when they're used for an orphan disease, they're still at the same cheap price. And so this is another reason why I'm so enthusiastic about off-label drug use and drug repurposing for rare diseases, because not only are the drugs already approved, and not only are they already demonstrated to be safe and effective for at least something, they're also often typically a lot cheaper than these other orphan drugs that are being developed. So I think from a societal perspective and from a patient perspective, repurposing is really, really exciting. But to your point, because the drugs are cheaper, that also means that there's less of an incentive for drug companies to want to spend what is significant funding to understand if the drug actually works in a rigorous fashion. And so for us, that's involved a combination of philanthropy, so individuals in the Philadelphia area and also in the Raleigh, North Carolina area, which is where I grew up, contributing funding to fund research into Castleman disease, to help to fund this clinical trial. We also were fortunate that we were able to get federal funding to fund the vast majority of this trial from a federal grant from the NIH. But just as you said, there are a lot of rare diseases and there are a lot of drugs that need to be investigated. And I really hope that through my efforts with chasing my cure and this book, and also my efforts with the FDA to try to shed light on this concept of drugs that already exist that we may be able to start repurposing right away. I hope that can help to drive and at least encourage some additional focus on this question of, how many drugs already exist that we just don't even know about.
One of the things that you describe in your book is this challenge of coordinating treatment and research. Because when you first started, there were just a handful of doctors, and they weren't necessarily communicating between themselves about how to approach Castleman disease. I suspect that that's also true for a lot of rare diseases. You might have a doctor in the Netherlands who's doing something interesting and somebody else in Minneapolis, but they may not be talking to one another because there aren't large conferences where everybody who gathers to talk about this disease and the research associated with it can actually talk to one another. So how are we going to, looking forward to dealing with rare diseases, help with the coordination?
You're exactly right. In Castleman disease, I remember being totally shocked when I first started trying to organize the first meeting and saying, when was the last time that all of you guys got together? And they said, we've never gotten together. And I was like, how in the world, are you guys the 25 leaders in this field and you've never actually met together or even spoken on the phone? Some of you may have emailed, some of you have written correspondences through medical journals. I was really shocked. But just as you said, this is an issue across rare diseases, and we've tackled it in the Castleman disease space by really revolutionizing the way that rare disease research can be done. Previously, in the kind of traditional way you do research is to raise money and then invite researchers to apply to use the money how they see fit, and then you pick the best applicant. And that works really well when you have hundreds of applicants and you have millions of dollars. But for rare diseases where you might have 3 applicants and $10,000, it's extraordinarily unlikely that the best researcher with the best research idea and the right skill set is going to conceptualize and come up with the best research idea at the right time. I mean, that's just pretty unlikely when you just have a few people thinking about it. So we've totally changed that for Castleman disease. We actually spent about 2 years just identifying all the physicians and researchers worldwide, all the patients that we could identify, and building a virtual community and also a community that gets together once a year, and then using that community to identify all of the research studies that could be done, prioritizing them into what should be done, and then going out and finding the best person in the world for each of our top priority studies. So it wasn't who wants our money and then we'll pick from your ideas. It was what do we need to do based on our entire community working together and then going out and hand picking the best person in the world for each of these studies. And we found that this sort of an approach has been so efficient for Castleman disease. It encourages collaboration. Everyone throws in their ideas. Everyone throws in their samples. It's not always easy to get everyone to throw in their samples, but this approach to research has really resulted in lightning fast progress. A lot of foundations talk about how 90% or 95% of their funding goes towards research. Over the last 7 years for the CDCN, we've raised and spent about $1 million on research. And from that $1 million, there's been an additional $7 million invested from foundations and the federal government. And so, some people say 90 to 95%. We can kind of say 700% of the dollars, of each dollar that we raised has actually been able to go towards research due to this collaborative approach. And it's something that I'm sharing about through this book and also through publications describing what we call the collaborative network approach. And we hope this is an approach that many other rare diseases can take on.
Well, you put the Castleman Disease Collaborative Network together fairly early on. Is it going to prove a model for other rare diseases, do you think?
I think so. There already are at least a dozen rare diseases that I'm aware of that are following the collaborative network approach. And earlier this year, we partnered with 2 large umbrella organizations in the rare disease space to try to actively share this model and make it available, make it so that some of the tools that we've created for Castleman disease can actually be utilized across other rare diseases, tools for upvoting and downvoting research ideas, tools for generating and crowdsourcing ideas for research topics, tools for communication between researchers. These are things we've built for Castleman disease, but we've started to collaborate with rare disease umbrella organizations to make these tools more universally accessible.
Dr. Fajgenbaum, I wonder in the 2 or 3 minutes that we have left, if you could share with our listeners what you learned while on what thankfully was not your deathbed. How can everyone turn hope into action, even in the darkest of times? And what advice do you have for individuals and their loved ones who are facing an extreme illness or a rare illness?
Sure. I learned that if you hope for something and if you pray for something, that you need to reflect on what that thing is that you're hoping for or praying for, and then figuring out what action can you take to get closer to that reality. For me, I was hoping and praying for a cure for my disease. And I was hoping, I guess, for someone else to figure out how to cure for my disease, or someone else to raise the money or to do the work to make it happen. And then when I ran out of options, I realized that if I wanted that, which I was hoping for and praying for, I would need to turn my hope into action. And so I got to work. And it wasn't because I actually thought I would identify a treatment that would save my life and potentially help other patients as well. It was because I knew if I didn't try that it wasn't going to happen. And I knew that if I did try, at least there was a chance it could happen. And so I really encourage anyone, no matter what you're facing in life. My story certainly is literally about me chasing a cure for myself, but I think it's really a universal tale of getting up and fighting back after life knocks you down. When I think about when I was on my deathbed for the first time, and I remember crying just down the street in the intensive care unit, where I was crying because I didn't think I was going to survive, and I knew I wouldn't be able to have a family with my girlfriend at the time, and I wouldn't be able to be a father. And here I am now 9 years later, and I got married to that person, the love of my life, Caitlin. I had a daughter with her 13 months ago. We have that family that I had mourned not being able to have, and it's only because I turned my hope for a future into action, and I'm continuing to try to turn my hope for an even longer future with my wife and with my daughter. I realize that I've been in remission for 5.5 years, but I don't know if I'll make it 6 years. And so I have work to do, and that continues to motivate me and to inspire me to keep pushing things forward.
Dr. David Fajgenbaum, thank you so much for talking with us on the People's Pharmacy today, and thank you for writing Chasing My Cure.
And inspiring so many other people who will follow your lead and make change happen.
Thank you so much for having me. I hope we can turn it from chasing my cure into chasing our cures.
You've been listening to Dr. David Fajgenbaum. He is Assistant Professor of Medicine in the Department of Translational Medicine and Human Genetics at the University of Pennsylvania. He's also Associate Director for Patient Impact of the Orphan Disease Center at the university and co-founder and Executive Director of the Castleman Disease Collaborative Network. His book is Chasing My Cure, a doctor's race to turn hope into action.
Dr. Fajgenbaum's website is chasingmycure.com. And I really love his message. It's in the future, we all hope it's chasing our cures, and we should all be acting on our hopes and prayers.
Absolutely. Lynn Siegel produced today's show. Al Wadarski engineered. Dave Creighton edits our interviews.
The People's Pharmacy is produced at the studios of North Carolina Public Radio, WUNC.
The People's Pharmacy theme music is by B.J. Liederman.
The People's Pharmacy is brought to you in part by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome. Online at Verizana.com.
And by CocoVia, maker of high-potency cocoflavanol supplements that support cognitive and cardiovascular health. More information at cocovia.com.
To buy a CD of today's show or any other People's Pharmacy broadcast, you can call 800-732-2334. Today's show is number 1193. The number again, 800-732-2334. You can also find it at peoplespharmacy.com.
And when you go to our site, you can tell us your thoughts about today's show. Do you know someone with a rare disease? Please share the story in the comments section of the show. It's number 1193.
At peoplespharmacy.com, you can also sign up for our free online newsletter or subscribe to the free podcast of the show. You'll never miss another episode, and you can share it with a friend. In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thank you for listening, and please do join us again next week. Thank you for listening to the People's Pharmacy Podcast. It's an honor and a pleasure to bring you our award-winning program week in and week out. But producing and distributing this show as a free podcast takes time and costs money.
If you like what we do and you'd like to help us continue to produce high-quality, independent healthcare journalism, please consider chipping in.
All you have to do is go to peoplespharmacy.com/donate.
Whether it's just one time or a monthly donation, you can be part of the team that makes this show possible. Thank you for your continued loyalty and support. We couldn't make our show without you.